Okay, hi. If you are my student, you can take out your pen and start writing. This chapter is mainly about memorizing quite a bit of things. So yeah, and if you're not my student, do note that there are certain parts of this lesson that missed out because it's easier to teach for understanding during my lesson. So if you want to know or have any queries, you can email and contact me. I will respond as fast as I can. Okay, so let's start. Okay, so for electrolysis, there's mainly two parts. Okay, one is called electrolysis. Yeah, obviously, right? Okay, which means that you use electricity to break down chemicals. Okay, and the other one is called electric cell. Okay, electrolysis, and the other one is called electric cell. Okay, electric cell is basically using chemicals to generate electricity. Okay, so there are two parts. One is electrolysis, use electricity to break down chemicals. The other one use chemicals to generate electricity. And last one is fuel cells, specifically made and compulsory for this year's syllabus, for GCE levels. Yeah. So let's go through the first part, electrolysis. Okay, so electrolysis has four main parts. Uh, So for each part, we are going to draw the diagram and write the word. Okay, and that's what you need to memorize. For the method and the logic, do remind me to go through that with you during the lesson because that's also required for you. Okay, so first, draw the diagram. I do not need you to write the battery, electrode, and electrolyte, but you need to draw the whole diagram. Okay, first draw the battery or the cells. Then do note that the longer side means positive, smaller side means negative. So the one connected to the longer side, draw the rectangle. Okay, the one connected to the longer side is the anode for electrolysis, and the one connected to the shorter side is the cathode. Okay, I repeat again. The one connected to the longer side is the anode. The one connected to the shorter side is the cathode. Okay, pause the video if you need to. If you're done drawing, I will move on. Okay, next thing for the electrodes. Okay, for the electrodes, instead of writing electrodes, label them inner electrodes. Okay, in your syllabus, there are two main examples of inner electrodes. One is platinum, the other is graphite, which is actually carbon. Okay, and then for the electrolyte, okay, in this example, we are going to use molten NaCl liquid. You can write NaCl liquid or you can write molten NaCl. Either one is fine also. Okay, after writing that, okay, we are going to write the ions present. So in this case, it's just molten NaCl in the electrolytes. Okay, so molten NaCl is just Na plus and Cl minus. Now next thing, we are going to write at the anode the equation and at the cathode equation. So write it down. So the anode is 2 Cl minus and liquid, in this case, arrow Cl2 gas plus 2E minus, which is the electron. Next one, cathode is Na plus liquid plus E minus arrow Na liquid. Okay, for my students, please write them down because at the end of the lesson, I will look at them. Thanks. Then the overall equation is just combining both equations, the left hand side, and combining both equations, the right hand side. Okay, you do realize that there isn't any electrons returned because later on both sides, the electrons will cancel out. Okay, and make sure that the electrons are balanced. So now here you see that one is two electrons, the other one is one electron. So you multiply the second row by 2. Okay, so you have 2 NaCl, blah, 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 blah. Okay, again, pause the video if you need to write down and continue. Okay, so for every equation, you need to know the conclusion, the ultimate effect on the whole setup. So in this case, this, okay? Okay, so effect on electrolyte basically is just broken down into Na liquid and Cl2 gas. Okay, pause if you need to. If not, I'll continue. Okay, for the second diagram is NaCl equals. Okay, equals means dissolve in water. Okay, so I need you to draw the diagram again. Okay, this time after drawing the diagram, okay, label the electrodes to be the same, either platinum, which is Pt, or C for graphite, and they are both inert electrodes. Then the electrolyte label NaClAq. Now, if they did not mention the word concentrated, it means that it is dilute. You can automatically assume that it's dilute. Okay, so you put AQ, and I don't need to write dilute because no indication means dilute. Next, okay, write down the ions present. Now, because it's AQ is dissolved in water, so there are two extra ions, H plus and OH minus. After that, right at the anode, what happens? This equation, memorize. It's the standard one for OH minus. And at the cathode, this equation, again, memorize, is the standard one for H plus. Okay, now, for the overall equation, you can combine them, derive them from the previous two. I think the more direct method is just to memorize this one also. Okay, it's just H2O produce H2 and O2 gas. Okay, now you can pause the video. If not, you can write down. If not, if you're done, I will move on. Okay, so later on, after the next example, I will explain to you how to choose which ions at this chart. But now we can see that for the anode, this one disappear. For the cathode, this disappears, right? Now, if that's the case, then the ions remaining will be Na plus and Cl minus. Okay, do cancel or circle whatever for the ions present. Now, because of that, in the solution there are only these two ions. So essentially, you are making the water disappear. Okay, so your right conclusion, NaCl solution becomes concentrated as H2O is electrolyzed. Okay, pause the video if you need to. If not, I will move on after erasing all the highlights. Okay, now for the third example, okay, in total there are four for electrolysis. So when you're done with four, you can go back and check. Okay, now the third one is this. Okay, again draw the diagram. Okay, again write the electrodes, either platinum or graphite carbon. Okay, platinum is more expensive, that's all. Okay, next one. Um, you realize that in this one, in this example, it is written as concentrated. Okay, concentrated NaCl AQ. Okay, AQ means dissolved in water, so there will be H plus and OH minus. Concentrated just means that there are more Na plus and Cl minus ions. Okay, so next thing, write ion present. Sorry, ions present. Write the four ions. Okay, then we write the equation at the anode and at the cathode. Okay, so at the anode this time, because it's concentrated, 2Cl minus AQ arrow Cl2 gas plus 2E minus. Then at the cathode, it's the same one as the previous one. Okay, so the overall equation is just combine the two, but make sure the electrons are balanced for you to cancel them out. Okay, so in this case it's two electrons, yeah, you can remove them directly without multiplying. Okay, so pause the video if you need to. If not, I'll continue after erasing the highlights. Now, you will ask why this is Cl minus. Okay, now for that, the logic is this. There are specific ions. Remind me during your lesson to tell you what are the specific ions. But for group 7 ions, so now for group 7 ions, and OH minus ions. So you realize that at the anode, okay, the negative ions are discharged. So what are the negative ions? OH minus and Cl minus. Now, if you're comparing OH minus and Cl minus, it depends on concentration. Again, I say again, it depends on concentration. So if the solution is dilute, it is OH minus. Okay, if the solution is dilute, it is OH minus. If the solution is not dilute, and in this case it is not dilute, concentrated, then we will take the Cl minus. That's all for the negative ions. Then for the positive ions, okay, which will go to the cathode. okay, which goes to the cathode here because it's negatively charged. This cathode is negatively charged, so you will attract the positive ions. Now let's look at the positive ions. They are H plus and Na plus. Now for positive ions, it's more straightforward. The less reactive one is preferentially discharged. So you need to memorize the reactivity series, including the H plus inside. Okay, so we can look at my video for the reactivity series, the metals chapter. Okay, yeah. So you can pause and replay this section, um, or email me or ask me during the lesson. And other than that, we shall move on. Now, I'll erase the highlights. Okay, let's see now. If we look at what are the ions that are discharged, is Cl minus and H plus. So I will highlight them. So you can circle them on your paper or highlight them. Then you realize that the remaining ions are Na plus and OH minus. Now if the remaining ions are Na plus and OH minus, write it down, it becomes more alkaline. Okay, so yeah, you can pause the video and write everything down, okay, while I erase the highlights. If not, you can continue playing and I will move on. We are the fourth example of electrolysis, and that is electroplating. Again, draw the diagram. Okay, now when you are done drawing the diagram, this time we label. Now do note, this label is slightly different. We are using non-inert anode. Okay, which means the anode can be any metal that you want to coat with, and cathode is the object, okay, that you want to coat. So in this case, as I use a teapot as an example, you can label it as object, up to you. Okay, again, anode is this guy, the one connected to the positive side for electrolysis, and cathode is this guy, the one connected to the negative side for electrolysis. Okay, you can pause the video if you need to. If not, I'll continue after I erase the highlights. Now, after labeling the electrodes, we can start labeling the electrolyte. Electrolyte in this case, I'll use anything that contains the same as the anode. Okay, so I will use CuSO4, AQ. AQ means again dissolved in water, right? Okay, so we write ions present, Cu2 plus, SO4 2 minus, H plus, OH minus. Okay, then now we will pause the video if you need to, and then I'll move on. Okay, so next one, we'll write the equation at the anode. So equation at the anode is basically the anode dissolving. Okay, and equation at the cathode is basically coating. So the discharge of the ions from the aqueous solution into the solid. So you form deposits there. Okay, so this part dissolve, this one dissolve, this one form. So the easier way to remember is just to tell yourself electroplating, anode melts. Okay, just 2 words, anode melts. Okay, anode melts, solid become aqueous ions. Okay, again I repeat, anode melts. Okay, so yep, when you're done writing the 2 equations, you can play the video again. Okay, so overall is the electroplating of the object at the cathode. Okay, it can be a teapot, it can be whatever, your watch, your phone, whatever. Okay, next thing, we'll identify ions meaning. Again, if there's excess, usually they'll put excess so that you know the electroplating process will continue. Okay, now next one, we'll see what is observed. So initially the anode will dissolve. So you write down anode dissolves into electrolyte. Again, depending, you can write change the word electrolyte to CuSO4 AQ. Okay, or you can write the question mentioned. Okay, then the next one is deposits are formed at cathode. If your teacher mentioned the color of the deposit, write the color too. Okay, next one. Okay, this is at the initial stage, and after some time, a long time has passed. So sometimes they'll ask this in the question also. After a long time has passed, what happens? You will say the electrolyte decolorizes as all Cu2 plus. Again, oh sorry, this 2 plus need to be in the top right hand side. The 2 plus. Okay, you should write it like that. Okay, so you write all Cu2 plus ions in electrolyte are discharged at cathode to form Cu deposits. Electrolyte decolorizes. Okay, you can pause the video and write everything down. If not, you can continue. Okay. I will continue after I use highlights. Yep. Okay, we are done with electrolysis. So electrolysis, I just give a short recap. Electrolysis has four parts, four types of electrolysis. First three are basic electrolysis, and the last one is electroplating. Okay, so for the first three electrolysis, the first one is NaCl liquid, second one is NaCl aqueous, bracket dilute. Okay, and the third one is NaCl concentrated. Okay, that's all. And the fourth one is electroplating. That's all for electrolysis. So now we move on to electric cell. Now, electric cell is to use chemicals to, or specifically the electrodes to generate electricity. Electrolysis is to use electricity to break down the chemicals. Okay, so again, you are going to draw the diagram. This time, you don't need to label, but draw the diagram, and you should notice that the difference is this: you do not have an electric source, no batteries, no cells here. You can draw anything, you can leave it blank also, you can draw just a straight line will do, also can. Then you draw two electrodes. Now for the two electrodes, they are the ones that cause the generate the electricity. So the reason is that they have different reactivity. Okay, so you can put two metals. In this case, I put Cu solid and Mg solid, which is copper and magnesium. Now we should know that magnesium is more reactive than copper in the reactivity series. Okay, so one thing to memorize is the more reactive one, the more reactive metal becomes ion. The more reactive metal becomes ion. Okay. Now, and the less reactive metal will just act as a conductor. Okay. So, label the electrode Cu and Mg. Label the electrode Cu and Mg. Okay. And then label will start identifying. So the Mg one, let's say one of them is Mg. Okay. This one is, let's say this is Mg. The electrons will flow this way and come out through the copper one. Okay. Next thing, write the equations. Okay. So at the Mg electrode, okay, at the Mg electrode, what happened, and at the Cu electrode, what happened? Okay. So at the Mg electrode, again, more reactive becomes ion. Okay. So we write Mg solid arrow Mg2 plus bracket Aq plus Ce minus. Then the other one at the Cu electrode is discharging. Okay, it gives out electrons, it discharges the positive ions. Okay, now in this case, we use the electrolyte, label the electrolyte AgClAq. Then we write what the ions present. The ions present are Ag plus Cl minus, H plus, and OH minus. Okay, now because of that, we know from the previous part in electrolysis, the less reactive one are preferentially discharged. So you just write 2H plus plus 2E minus arrow H2 gas. Okay, again, the overall is just combining the two equations. Before that, you need to make sure the electrons on both sides are balanced, which is 2E minus and 2E minus. Then you just combine the left side, left side, right side, left side. That's all. Then next one, we know that the ions remaining are these three, okay, because we know H plus is discharged already. Okay, so the conclusion is solution becomes alkaline because of the OH minus. Deposits form at cathode, anode dissolves because anode forms ions, right? Okay, yeah, that's it for electric cell. You can pause the video if not, you can continue, and I'll move on after using the highlights. Okay, so for this part, electric cell, again, after asking you the things that I mentioned in the previous slide, they will ask a few more questions. So they will say, sometimes in the MCQ, they will ask which one can generate the largest voltage or whatever. So you will see the reactivity series. Okay, so the further apart they are, the two metals are in the reactivity series, then the larger the voltage. Okay, so you need to memorize the reactivity series. You can refer to my video on metals. Next one, the more is the next one is the logic on the which electrode becomes ions, okay, or melts or dissolves. Okay, this one, okay, the more reactive metal dissolves. Okay, the less reactive metal acts as a conductor. So that's There's the two main logic for electric cells. That's all. Okay. If you need to write down, pause. If not, I'll move on. Okay, we're at the last part now. This is fuel cell. Okay, fuel cell is basically just memorizing what goes into the fuel cell and what comes out, which is the byproduct, electricity, and labeling of the diagram and the equations. That's all. So I'm just going to flash, not flash, but I'm just going to show you the two diagrams. Usually your teacher will teach one of them, so just use one of them will do. Yeah. So now I will move on. Okay, as I mentioned before, you just need to memorize what goes in and come out, and the equations and the directions of electron flow. Yep. So here's the diagram, and the main point is to know the direction of the arrows, what goes in, what come out, and the electron flow. Okay. Why I show two diagrams? One is the acid hydrogen fuel cell, the other one is alkali hydrogen fuel cell. So depending on your teacher's choice, okay, I just recommend doing both. Okay. Now next one, you need to write down the two equations and the overall equation. Okay. For the two equations, you know there's no half right in the equation, so you can just multiply everything across by 2. Okay, same here, you just multiply everything across by 2. Okay. When you're done writing down what is highlighted, you're done. And that's all for electrolysis topic.